I'm Beau Woods. I came to talk to you today about car hacking, the security behind some of the devices that have adopted connectivity and computer technology where we say bits and bytes can meet blood and bone. So my first day working in the InfoSec field, I was super excited. I was a security analyst at a small to medium-sized hospital in the U.S. And my first call on the first day was a physician calling. He said, you know, we've got these devices in the natal intensive care unit that help us monitor the baby's heart rate and some other conditions so that we can give them the treatment that they need for the premature babies that are born early, make sure that they get the best shot in life. Well, these devices aren't working right. They keep going down, and when they come back up, they've got this Windows screen. Now, I know you're not certified to work on medical devices. You're not a physician, but you know computers. I wonder if you could help me. So I went over to the natal intensive care unit, and I saw these systems, and I said, yep, that's what they're doing. Dug into it a little bit. We'd had a network worm, and it was called Zotab. Traced it back and said, yeah, it's got the same symptoms as the other systems that were infected with Zotab, but it's doing something slightly different, and it's a little bit more important because, you know, this is patient health care on the line. I called the medical device manufacturer. They said, oh, we're sorry, sir. Because that has a network worm, we're not able to fix it. It's out of warranty. It's out of support. I said, wait a minute. You made this device. It got infected due to your poor security. Now you're telling me that you can't fix it? I said, that's right. All right, fine. I'm not going to argue with you. Let me into the system so I can fix it myself. I know how, right? They said, I'm sorry, sir, we can't allow you to do that. It's a medical device. We can't let you change it. Wait a minute, it's already changed. All right, this is crazy, this is chaos. I hung up the phone frustrated. In the next couple of minutes, I realized, hey, you know what? I'm a hacker. If some dumb network worm could get into this system, I can get it too, right? So with my boss, I put together a plan to go to the CEO. We outlined what the problem was, the devices weren't working, why we wanted to solve that problem, how we were going to do it, and potential outcomes. In the next 30 minutes, he approved the decision to use hacker attacks, basically Metasploit toolkit, to break into the device, find the virus, kill it, delete it off the system, apply the appropriate patch, reboot the system. Before the end of the day, we had all the devices in the natal intensive care unit back up and running. That was my first day in information security, and at that point I learned that sometimes the things we think about in terms of computers don't necessarily have the role of computers or the function of computers. They do other things. Over the last 18 months or so, I've been working with some colleagues of mine in a global grassroots organization, and the problem statement that we set out to try and solve was that our society is adopting connected technology faster than we're able to secure it. That group is called I Am the Cavalry. The idea is if the cavalry isn't going to come to save us like John Wayne and all the westerns in you know, the 50s and 60s, then we have to do it ourselves. We have to stand up and lead and take accountability and responsibility, even if maybe it wasn't our problem to begin with. And we decided to focus on these connected technologies, primarily automobiles and medical devices, where they're increasingly being driven by software and by connectivity. Before I move on, there was a joke that I read about Bill Gates, speaking of Bill Gates, Comdex, 1997. He said, you know, if only the car industry were more like the computer industry, right now we'd be going 100 miles on a gallon of gas, and we'd have, you know, 1/10 the cost of cars. And reportedly someone said, yeah, but who wants a car that stops working twice a day, and every time you buy a new one, you have to learn how to drive all over again? Well, this year, I heard a joke going around Toyota. Why do we put wheels on a car? To keep the computer from bumping the ground. So now we've come full circle. Cars are computers on wheels. if you look at the technology that's in these things, it's really amazing what it can do. There's so many safety features packed into the 2014 models of cars. It's amazing. One common thing, though, is that they are all enabled by connectivity, whether it's Bluetooth, Wi-Fi, 3G, whatever, and computers connected to sensors for automatic decision making. Now, as all of us know, if you have a computer, it can have problems. Those problems can be exploited by certain people we call hackers. If you want to think about it one way, all software has flaws. I think everyone would agree with that, right? Connectivity increases potential exposure to those flaws, right? So now, instead of driving or riding in an automobile, you're actually driving or riding in a vulnerable, exposed computer. So anybody who's taking a taxi to the next place they're going, or driving home, keep that in mind, but don't keep that too much in mind that you drive off the road. That would be a whole. This is a car that was taken apart by a couple of guys, Charlie Miller and Chris Balasek. They broke apart this car based on some research by the U.S. government in order to see how easy it would be to hack the car. Well, of course, if you have physical access to a device for like 6 weeks, anybody can hack it, right? I think we'd all agree with that. A couple of Spanish researchers took it one step further. They made this device, which you can see, it's really small. If you pop out a tail light, connect two alligator clips to the wires, put this device in there and put it back in 5 minutes, they have a 3G link to your car and they can do exactly the same thing. Well, still, it requires physical access. 5 minutes, and it's complete remote control, so it's still a little bit scary, but at least it requires physical access. Kind of. So in 2010, some researchers from the University of California, San Diego, were working on some cars, again, with the support of the U.S. government grants, to see if they could get in by the 3G modems that are built into cars now, right? If you look especially in the U.S. market, all GM vehicles are equipped with something called OnStar, which if somebody steals your car, they can disable it. If there's a crash, somebody can call you and see, are you okay, and we'll send paramedics. Well, the researchers were able to basically call a bunch of phone numbers, find one that was a car, and then start sending SMS texts, which were commands to the car. Old-fashioned war dialing. Well, but at least, that's only if your car has one of those, right? Well, that's not quite the end of the story either. This is a device that hooks into any car made after 1996, which has an onboard diagnostics port. Onboard diagnostics is a standard. Almost all cars since '96 have it, and even some earlier cars. It allows you to get access to certain computer functions within the car, to be able to tell, what's the fuel mix look like, fuel to air ratio, what do the exhaust look like, are there any engine codes. This one in particular connects to the onboard diagnostics and then forms a Bluetooth link. So you can connect to it over your phone and read the onboard diagnostics. A couple of weeks ago, some Chinese researchers were looking at these. They looked at 19, and about half of them would allow you not just to read things that the car's engine was telling you, you could tell the car to do things. Unlock the doors, kill the engine, honk the horn, some of these things. Well, as it turns out, a lot of rental car agencies and insurance companies in the U.S. are installing these so that they can monitor driver behavior, so they know if you're driving recklessly, they can charge you more for your insurance. Or if you're speeding, the rental car agencies can say, hey, you were going 100 miles an hour through a school zone. You can't drive our cars anymore. You're too much of a hazard. But at least this is an aftermarket thing, and we don't have to worry if we don't have one of those, right? Well, again, that's not the end of the story. So last year, in October 2013, Toyota settled a lawsuit. There was somebody in Oklahoma, their car's accelerator got stuck, and they couldn't apply the brakes to stop it. So essentially, the car accelerated out of control. The driver lost control of the car and died. Through forensic investigation, some people found that some of the basic safety controls on the car weren't in place the way that they should have been. That the software had a buffer underrun, and that's what caused the accelerator to get stuck. So now, we're building cars and other things that are so fragile, we don't need a hacker to break it. It breaks itself, right? This is the bus layout of a car. I don't want to go into any of the details. If you want to check it out, you can. The point of this is it's very complicated. Each of those dots is a sensor or a computer. Each of those lines is a network connection. It's not talking IPv4. It might be talking ICCP or one of the other strange protocols that most of us in this room don't speak the way that we speak IPv4. But it is connected, and it is possible to talk along this network, which actually acts as a hub. Most of the people in here know what a hub is, so I'm comfortable using that language even though you're C-level executives. Going through this, we discovered that one of the reasons why this situation exists is there's many different people who are working on building cars. You have the engineers who are making amazing things, right? They're taking known science and turning it into practical reality every day. That's fantastically hard, and they do a really good job of it. Policymakers, politicians, they want to make sure that everything is safe and that the status quo is maintained for the most part. They go about their job, and if there's nothing that's really broken, they don't want to mess with the system because that's how things get broken in the first place. Security researchers find these things, but then they don't always necessarily tell people what they found, or they say it loudly and they go and talk on stage, but then they don't follow up with recommendations. They don't reach out to the manufacturers to get these things fixed. And there are a lot of other stakeholders involved too. As I was going through this presentation, I realized that CISOs have a lot of these same exact demographics as their stakeholders, right? You've got the business line people. They make amazing, fantastic products that everybody wants to buy, right? They do a great job of that, but they don't always talk to other people. The executives and the board of directors, they want to make sure that this ship is sailing straight, that it's going right, that it has everything it needs. If there's nothing that's broken, they don't want to break something. In the security organization, it's a little bit different because you're involved within that organization. But by and large, you have a lot of the same players. And so I thought maybe some of the things that we've learned in the last 18 months, dealing with these large, complex problems, multi-stakeholder models, big corporations, a lack of direct influence with them, maybe you guys could benefit from some of that lessons learned as well. Going back to the panel we had. Maybe we can learn some things from failure and others from success. So what have we learned? Well, technology isn't always about technology. It's decisions made by people. We've gotten to the point where we no longer have to ask, can our technology do this? The answer is always yes. But we haven't yet gotten to the point where we ask, what should our technology be doing? If somebody comes to you from the business line and says, hey, we want the technology to be able to do blah, blah, blah. Can it do that? Absolutely. But maybe dig a little deeper. Why are you looking to do that? Let me help you come up with a good solution that works for you. I can help you define the requirements so we do it in a safe, secure way. We also need to keep in mind we need better cooperation among all the stakeholders. We're not alone in this journey. We want to invite others with common areas of expertise and concern. And then we don't want to wait for catastrophe to happen. We want to prepare for it and act before it happens. How do we know that we've succeeded? I think A measure of success is empowered stakeholders, right? Enable people, don't dictate to them. Once you have the stakeholders inviting you to that conversation, you know you've succeeded. Bringing in a concept of supply chain management with software, right? Most of you already know how to manage your supply chain, or most organizations know how to manage supply chain and do it really well. Well, think of software as part of your supply chain management. That can help you. Have a supportive power structure with aligned incentives so that you're all pulling in exactly the same direction, not slightly misaligned. Involve others towards a common goal. Once you have that common incentive structure, finding a common goal should be easy. Allow hot rodding of cars in your own environments, right? BYOD is a great example of this. Bring your own device. Find a safe, secure way in your environment to enable business leaders to do the things that they need to do to support and promote their business. And I wanted to give you 4 things to do Monday. 4 things to do Monday that could be very easy. Invite an executive or a business owner to lunch. It's amazing what you can get accomplished just by sitting down with somebody. You don't have to look at them in the eye for 30 seconds like we did in that exercise. That's really uncomfortable. But, you know, maybe over the course of lunch, if you look at them in the eye for 30 seconds, you'll have a little bit of empathy with them. Identify 3 accountability misalignments where decision-making is in the wrong place, and then somehow you can look to fix that. And then, you know, commit to taking one security experiment. Do something that maybe goes against the grain or the established methodology, but the established methodology is usually wrong, or it almost always leads to failure. Try something different so that we can truly learn. Ask one vendor about the epistemology of their solution. And by epistemology, I mean, you know, what is the problem that you're trying to solve? You know, is that the problem that I have? I don't know. How do you know that you've solved it? And then how do you know that it was your solution that solved it? So don't let them just come in and you know, slick white papers and say these are a few cherry-picked case studies. Really ask them, impress them on that. And then engage willing allies outside of your organization, whether it's you know, third-party researchers. Just bring other people's advice and guidance to the table that helps at least expand the number of solutions you have to choose from. And so that's all I have for today. Thank you.